Hello, students. Good morning to all of you. I hope the exam was successful, the midterm too, and all of you have performed very well. And now you're planning to go for the end term examinations. So, just one or two topics that are left. Let me cover up today. Today, we will take up a very important topic of inventory management known as EOQ, Economic Order Quantity. Now, this is the deterministic inventory model. Deterministic inventory model means you know exactly how much will be the demand for a year. There is no probabilistic fluctuations. It is deterministic. So on a deterministic inventory model, EOQ serves a very scientific method of achieving the goal. And what is the goal? The goal is you want to know exactly how much to order. Say for example, you have this large span as a year. Year is this much. And you know that you need X amount of items over the whole year. Now, will you purchase X amount of items at the beginning of the year, or you will purchase X amount of items over the year? The scientific method says that you should purchase over the year, because if you purchase X amount of items at the beginning of the year, your inventory will be huge and your inventory carrying cost will be a very high cost. In EOQ models, there are two costs that are taken into consideration. The first cost is inventory carrying cost, and the second cost is inventory holding cost. And the third component of EOQ model is annual demand. So what is inventory carrying cost? Inventory carrying cost is if you have your inventory with you, you have to keep it in the warehouse, the electricity of the warehouse, the supervisors of the warehouse, the all the personnel apart from the supervisors, their salary, insurance of the inventory, after your there are chances of inventories getting outdated. There's a chance that the inventories will no longer be used or required in the future. So there are plenty of things which are there if you keep the inventory at a time, a huge inventory. Okay, but at the same time, if you order too high an inventory, the ordering cost becomes low. If inventory order is very high, the inventory ordering cost becomes low, but carrying cost becomes high. It is absolutely this proportional. If this is your inventory ordering, if this is your inventory level, how much you want to purchase, the more you want to purchase, the inventory carrying cost is a linear function, is assumed to be a linear function, inventory carrying cost. An inventory holding cost is assumed to be a like a negative exponential function. So there is a point where the two functions meet, this function and this function. There's a point where the two functions meet. This point is the EOQ point. I will show you in the model. Just look at this picture. This is the quantity to be purchased. This is the inventory carrying cost. This is the inventory ordering cost. Carrying cost is same as holding cost. This is inventory ordering cost. So ordering cost will come down as you purchase more and more inventory. because you are purchasing at a time. So recurring costs are not involved. But inventory carrying cost will go up. As I told you, there are two costs that are involved in inventory: inventory ordering cost and inventory carrying cost. Okay. Now, if you mix these two curves, you get this kind of a function. Using minima, you can locate the minimum point of this function. This is the EOQ. This point is the EOQ point, the X value. Okay. Now, the formula for EOQ, write it down very carefully. It's a very simple formula. Whole root 2 into D into O by H. Whole root 2 into D into O by H, where D stands for the annual demand, O stands for ordering cost, and H stands for carrying cost, inventory carrying cost, mostly expressed as percentage of the inventory cost or cost of the item. So this is the EOQ model. Now there are some assumptions in EOQ. The first assumption is supply is available in the market and goods can be procured as and when required. So supply is constantly available in the market. That is the first assumption. There is no place or no point in a situation where the supply is blocked. It is a normal condition, normal market condition. The quantity to be procured is pre-decided. How much you need in a year is pre-decided. It does not fluctuate. And the prices of goods are constant. So whatever goods you want to purchase remains constant over the year. There is no fluctuation in the price of goods. Under these assumptions, you develop the EOQ model, that is root over 2 into D into O by H. O is the ordering cost, H is the carrying cost, and D is the annual demand. So this is the inventory model or economic order model that is there. Now, this is a scientific approach towards developing a model. Why is a scientific approach? Because you may think in a whims that I need 10,000 quantities, I will purchase it in 4 times. So I will divide 10,000 by 4. You whimsically think that I will purchase it in 3 times. So 10,000 divided by 3. So these whims are taken apart. Those are not considered anymore. You are only considering your scientific way of calculation where your cost is minimized, where the total ordering cost is minimized. That is economic order quantity. This is the role of EOQ. Now I'll take up a problem. I'll give you a problem. You may write this down. A company annually uses 24,000 units of raw materials costing rupees 2.5 per unit. Please write down the problem. A company annually uses 24,000 units of raw materials. 24,000 units of raw materials costing rupees 2.5 per unit. Considering each order costs rupees 30 and the carrying costs are 15% per year per unit of the average inventory, find the EOQ. Considering each order costs rupees 30, that is each order costs rupees 30, that is the ordering cost, and the carrying costs are 15% per year per unit of the average inventory. Now what is average inventory? Average inventory is EOQ by 2. is the average inventory formula. Okay, somewhere it is required in some problem this is not required. Here it is given, so you have to find out accordingly. Now, how will you solve it? Your What is your D now? Put in the formula. What is your D? That is annual demand. Annual demand is 24,000. What is your ordering cost? Ordering cost is 30 rupees. What is your inventory carrying cost? Inventory carrying cost is 2.5 rupees. Now, H is 15% per year of per unit of average inventory. Now 15%, the carrying cost is 15% per year per unit. Now it is told in the problem, you will see the company annually uses 24,000 units of raw materials costing rupees 2.5 per unit. So per raw material it costs rupees 2.5 per unit. Now what is the carrying cost? Carrying cost is 15% of 2.5. That is 0.15 into 2.5. That is 0.375 is the carrying cost. That is H. So your Q formula becomes 2 into 24,000 into 30 divided by 0.375. 2 into 24,000 into 30 divided by 0.375. 24,000 is the annual demand. 30 is the ordering cost. And 0.375 is the carrying cost. It is given in percentage as 15% of per year per unit. Per year per unit. So you are calculating basis on per unit. So that gives you 1960 units. So you should purchase 1960 units at a time. Okay. Another problem, from the following information, find out the EOQ and the total variable cost associated with the ordering policy. Take down this problem and if you can solve it. From the following information, find out the EOQ and total variable cost associated with the ordering policy. Annual demand is 50,000 rupees. Ordering cost is 200 rupees per order. Inventory carrying cost is 40% of average inventory value. So since nothing is mentioned in this problem, one modification will be your age will be just 40%, 0.4. You will consider age as 0.4. All the other things remaining the same. Okay, so this is your EOQ model. Now EOQ models, what are the advantages? The mathematical approaches helps in reducing personal bias and makes decision more factual. Personal bias are removed. The use of formulas is useful if you plan to use computers for calculation purpose. It is helpful in calculating the inventory level with the use of formula in the computer. So use of computer, you're using computer, then the use of this formula is easier to process, and it can give you a correct picture of the inventory and the inventory requirement. Mathematical approach is more reliable, obviously, than whimsical approach, than judgmental approach. For normal conditions, the formula does not need to be moderated. The formula remains the same. There is no need to moderate it for normal conditions. For abnormal conditions, the formula needs to be moderated. What can be the abnormal conditions? The abnormal conditions can be EOQ with quantity discounts, that is a single price break model, multiple price break model, but we are not going to do those things. We are limiting ourselves to only EOQ. The model is used by various business departments such as production department and inventory department. This model can be used for making reliable estimates. It can be used for creating automatic charts as the formula can be used for calculating reorder point and lead time. Reorder point it is used to calculate the reorder point. I'll read this out again. It can be used for creating automatic charts as the formula can be used for calculating reorder point and lead time. So what will be the reorder point? At what point you will order? And the lead time. Lead time is when you put the order and the time when you receive the order. This time gap is called the lead time. So estimating all these things will become easier if you use the EOQ method of calculation. So this is the basics of EOQ that we have covered today. Thank you.